Alright, welcome back to Some Assembly Required. Today we're going to be talking about the cylindrical mate in Onshape using something other than a cylinder as our example. So stay tuned. Alright, so today we are going to be showing you how to use that cylindrical mate, and like I said in the intro, we are not going to be using a cylinder, like a hydraulic cylinder, to show us how this mate works. And instead of doing like we've done in the past where we kind of draw everything up, I kind of wanted to shift gears a little bit and show you guys how to use a very, very valuable resource, and we're going to import some stuff in. So if you jump on over, we are actually going to go onto a website called McMaster-Carr. You can just type in McMaster-Carr on Google or McMaster-Carr.com and it'll bring you here. Okay. Next thing you're going to want to do is make an account, and it takes a couple seconds. There's no verification. There's no nothing. But some of these models on here, you need an account to be able to download. So what's really cool is you can pull up all kinds of stuff. There's key stocks, staples. I used to use this for bolts until I found another trick I'm going to show you how to do today. But for what we're going to do today, we're just going to type in lock, L-O-C-K, and press enter. It's probably going to default to lock washers, so make sure you back up and you really want to just search for the word lock. And we're not going padlocks today, but if we scroll down, we're going to take these slide-bolt latches, and we're going to go ahead and pick the lift-and-drop barrel slide-bolt latches. The reason is we need a cylinder that we can move in two directions. Okay, so first one I picked was this number A, or letter A, part number 1441A32. So if you go ahead and click that, it's kind of a nice contrast. And you'll notice you should get here, you have this CAD button. I click this drop down and I can download all this stuff in 2D, 3D, but what we're going to do is click 3D SolidWorks, and we'll click download, and while that's downloading, if you click the product detail, it'll actually show you some stuff. So when I was doing this, the reason why I needed to make an account is I needed to know what size these fasteners were going to be that went in here, and it tells me number 7. But I kind of figured out some workarounds and some cool things that we can do. So let's jump into Onshape and we will show you what's next. So just like always, you're going to want to start a document, and you can do this from the home screen too, but I seem to like doing it this way. So if you click the plus down here at the bottom, you'll see this import button. So we'll go ahead and click import, and it's going to bring you to your downloads. Go ahead and just pick that folder, or that file that we just downloaded. Click open, and it's going to ask you if you want to import appearances, import material density. There's a bunch of these different things you can do. Everything I've always done, import appearances, always seems to work fine. So we're just going to say import, and you'll see up here in the little bell, it's kind of thinking, it's loading, and if we click on that, you'll see we got it is now completely uploaded. It's taken care of, and you'll see down here at the bottom I now have a folder called CAD imports, and in here I have that bolt. So I can go into this part studio and I can see there is my latch with the bolt, all the same colors. CAD imports, I can see that actual SolidWorks file, so if I ever wanted to download it again, I could do that as well. But this isn't about drawing on here. What we want to do is insert a new tab and create that assembly. So we're going to start with an assembly, and we're going to say insert from our current document, and I could pick each part individually, but if you click the parent drop down menu, you'll get everything. I'll click accept, and now we are good to go. So one thing I want to show you is we want to lock this plate. We want to fix this plate in. So we're going to wrap around to the back. We're going to right click here, and we're going to say fix, and now you'll see I can move everything else, including this barrel, but I can't move this plate here. But to keep things aligned, we're going to kind of do this as well. So I am going to fix that one in place as well, because these two hasps need to kind of stay together. And really all we're dealing with today is this barrel that's going to be sliding back and forth. So one thing I want to do, just for visual sake and to kind of figure out later on when we go to do our screws, I need a plate. I need something for this to attach to and mount to. I could go back in my part studio and draw it again, but a feature that's kind of overlooked, and we'll do a whole video on this eventually, but if you come in and do right here, let me zoom in for you really quick, and you see this one that says create part studio in context, go ahead and click that. It'll bring you this menu. So it's asking you to select an origin. I always just pick that center point, and we're good to go, and say okay. It's going to pop you out in another part studio. And what's cool is you see this part. Let me shut those planes off. You can see your part kind of in a like transparent, translucent kind of view, and then you're free to just sketch however you want. So now I'm going to make a base plate for this off that back side, and you'll see now I'm drawing on that face. So we can go to the bottom. I can even draw it from the top if I wanted to. I'm going to do a rectangle and just kind of eyeball some measurements, so we look like we need to be about 2 by 2. Maybe we'll go a little shorter. We'll go 1.8. That'll get me a little meat on both sides. Yeah, there we go, 1.8. And I'll do another one kind of centered here, and we'll tell it that these need to coincide with that. I think that one is, I picked the wrong line. There we go. That and that need to coincide with one another. There we go. And I want these to be horizontal with each other. There we go. We can come in and round all these corners. I know some of you guys that do a lot of the 3D modeling are wondering why I do my fillets before. I learned in 2D, and that's how I have kind of always done it. So we have a plate here now. We'll say accept with that 0.25. I can flip to the other side, and this is crucial that you do this because these are countersunk. I'm going to use these holes, so I'm going to use that back hole on all of these, bring them forward with us. We'll say okay. We'll accept that, extrude, and we'll go out 0.125. Now we'll go 1/4 inch, 0.25. And so now I have 2 mounting plates that are made in the design off of the piece that I have. And I know a lot of us are used to doing like top-down design where we build everything off of the last thing we drew. But this is a real quick way to kind of make something like this. So now I'm going to say insert and go to assembly and select the parts. I want part 1 and part 2. And now it'll bring me back over to my assembly with those pieces attached like so. Now the only problem is there's no mate to it. So really quick, if I wanted to, I'm going to do a fastened mate from this circle to that circle, just so those live together. And we'll do another one, a fastened mate from there to there. Solve that. And now we have a nice little hasp kind of set up, our locking barrel setup. Okay, so now the real reason we're here is to figure out this piece right here, right? So I've already kind of pre-done the math, but basically if we take this and we rotate this guy, we want to be able to roll up to here and be able to slide and rotate back. So I could use a slider mate and a revolute mate, but that's a lot. So that's where this cylindrical mate comes in. It's allowing you both. If we look at our slider mate, again, it only allows translation along the z-axis and our Revolute Mate, if it'll pull up, come on. Our Revolute Mate allows rotation about the Z-axis, but not always at the same time. Sometimes I end up messing it up. So this is where this cylindrical mate comes in. Now the easiest way I found to do this was to go off of this flat face here and this flat face here. So if I hold and then come to the center, we are now perfectly aligned, and we'll say accept. The problem we're going to run into, however, is that I have limits now. So if I slowly start going, obviously I can't go through that in the real world, and I need to stop at some point, right? We don't want this to go too far. It's kind of stuck in here. So we'll undo, get it back to where we had it. Okay. And if we double click on cylindrical, we can click our limits. And what I'm going to do here is I'm going to click limits. And what I came up with for my numbers for maximum and minimum angles, I took a picture of it, sorry, I'm going to pull that up really quick, is the math was for this Z to make it negative 0.109. And let's see if we go to the right. Okay. The maximum is going to be 0.57. Our angle minimum is going to be 0 degrees, and our angle maximum is going to be 120. So if we go ahead and accept that, I can still run into this problem, but now I can no longer go back this way, and I can no longer go back this way. So, and if we go up the other direction, I'm only allowed to go until I hit that bar, and move over the other way, and then come back down and close there. Okay, so obviously it would be great if I could put something here, and I'm sure there is, I just haven't learned it yet. I'm thinking probably one of these tangent mates or something else we're going to learn along the way, or some other combination of stuff. But again, I'm learning just as you guys are. But for every project I would need to do, this is going to showcase how I would need to do it. If I was showing a customer, I think I would probably just make sure I don't cross over the seam here. If I was doing an animation of some sort, just make sure you show what it's supposed to look like and how it's supposed to look. So that's going to do it for that part there. But now you guys are probably wondering, well, this isn't complete. How are we going to fasten anything here? Well, if we come back up to here to insert, again, I could switch back over to McMaster-Carr, and I can pull in some screws the same way, right? However, Onshape has this really cool feature where you can, pull from your other documents, but you can also pull from standard content. And this new feature that I found, I don't know how long it's been out, but it's really, really cool. So you come in and pick your standard, ANSI, DIN, ISO, any of your deals. We're going to stick with ANSI. But you have this auto size fastener, and literally you just pick the cylinder wall. So let's say that I had this at 1/8. Well, if I were to use this and click insert, it's going to allow me to put a 1-inch bolt in that hole, and that's obviously not going to work. That's way too big, right? But I technically, and this is where when I've talked to people in industry about students coming out and some of the issues, they're making stuff like this that can't actually exist. You can't actually make it. So I'm not really big on, let's undo that, on imaginary things, but maybe you don't know exactly what that hole size needs to be, right? But for quick, you can get auto size fastener. I'm going to click there, and now it's picked everything I need. I can come in here and change the length. Maybe I want that length to be 4 inches, and I could set my thread pitch, whatever. We'll say insert, and now I have these bolts ready to drop in, and I can just go in and add threads. Maybe I want a 4-inch, a 1-inch. We'll say insert. We'll go to there. Maybe I need only a 1/2 inch bolt. Remember, our plate's only a 1/4 inch. Maybe I want to show the different variations or whatever. And we have that one. I want to do that one again, so I would just click here. And I could change again. Let's change one to 0.75, and we'll put 0.75 on these guys just for sake of doing it. And insert one more time, and we can go from there. So pretty cool little deal to be able to show off what's going on. Some things I noticed, if you don't add those fasten mates, sometimes you add that plate in, you think, oh yeah, well, I put a bolt in it, I put a screw in it. You got to make sure that these mates that attach the like the latch to the blue and the silver, like wood, I guess is what it would be in this instance. It could be metal, I guess, too. But the plates, yes, you put a screw in it or a bolt in it on the computer, but it doesn't know what's what. I could also add a relation here if I wanted to. It might have been easier to do, but I liked dealing with this right here and limiting how much angle we could do here. So one other thing to note, if we do, let me pull this around really quick. I could come down here to that cylindrical mate and say animate, and I can animate each one and see, step that up a little faster, let's go 100. I can show what that would look like moving back and forth. The problem is it's cutting through that little lip right there. So before I would animate that, what I would do is bring this guy up. We'll do animate again. Animate my linear motion. We'll say OK. Step that up to 100. And we can see that guy move really, really well. Let's move it just a hair more. There we go. I was running into some issues. It was hitting the wall there again. So same thing. Make that a little faster. Let's make that 75. And you'll see it moves without any obstructions, and we can see that it's stopping when it would stop, and it's stopping at the extents of that slot there. After that, I could do the same thing here, and I could show animate, but this time picking that Z, and I could let it reciprocate back and forth to kind of see that moving up to its extends and then back down. So pretty cool little thing you can do. I know I saw somewhere that somebody is working on a multi-mate animation script for Onshape. I haven't quite seen it yet. I haven't messed with it enough. But obviously this would be one that would be really cool, where it could go up, then over, then back down on that rotation. So the more you learn about the mates, the better these tools are going to start being. So, but that's going to pretty much do it for us today. I hope you guys are enjoying this stuff. We are going to be doing, looks like pin and slot next week. I might change things up a little bit. We got a big fundraiser dinner coming up this weekend, so I might do some sub-day work for other people to figure out how to do some simple 2D drawings, get some workouts going. I got kids learning my Onshape packet right now in my class, so might have to throw some curveballs at them, give them some new stuff, because we're going to be busy these next couple weeks. We got homecoming the week after. I know I'm just venting like it's a video diary right now, but I'm here for you. If you guys have any questions, reach out in the comments, shoot me an email, find me on Instagram, whatever, but I'm here for you guys. So Again, that's going to do it for us. You guys take care. See ya.